So, hello guys, with the name of God Ram Ram, congratulations to my two students for cracking SD internship plus full time job offer off campus from Amazon of 51 LPA. Veom Goyal and Dev Madan, they did it this month only, so congratulations to them. Their attendance in the day live training was very high, and they used to attend my one-to-one mentoring as well on a regular basis, so the result was almost guaranteed for them. If you are someone who is facing problems in DSA, person can be different, right? Someone might be facing problem at the fundamental basic level, someone can be facing problems in medium level questions in DSA, and someone can be facing issues in hard level. So we have separate day live training for beginners versus intermediate versus advanced people. Apart from that, daily tracking is there, and most importantly, I am the person who does one-to-one mentoring of students. So if you need personalized mentoring and day live training from me, and you want a team which is ready to give you top product based companies and fangam job referrals whenever you want, you can check all the services given in this link. Like, I am not explaining everything, you guys can go through this link and understand. Now many people are giving WayFair online assessment, I know that, for SD internship role, and when it gets converted to full time, you get PPO, you get 30 lakh rupees in your bank account. So we are going to solve this very hard graph problem which was asked in Wayfair way. Okay, if you are someone who is only doing standard DSA questions from the bubble sheets, driver sheet, you will not find this question in those DSA sheets. You will not even find a similar question to this in the DSA sheets and in the top lists. Even if you do 200, 500, 700 standard, easy, medium, lead code, GFG problems, still you cannot solve this problem directly, because this problem tests your problem solving skills and thinking skills. So who will be able to solve it? Only the person who has done many hard unseen DSA plus company OA and CP problems on Code Forces, Code Chef, and many company OA problems on Graph, they can do it. Okay. So, what is the prerequisite if you are watching this video, this session? Please complete my free graph course from here. It will build up a very strong understanding to tackle new and hard graph problems. So scroll down and complete from year to year. This much you need to do. I will assume in this video that you have done this much. Okay. For OA of companies, please prepare hard unseen DSA plus OA plus CP problems, and please stop relying on easy, medium, standard DSA problems based on standard DSA patterns and standard influencer DSA sheets. Go beyond, improve in your life. Out of box thinking is needed. Out of box thinking is needed. So these things you understand now. Going to the question, you can see what they have written is that you are roaming in a forest. This forest can be viewed as a graph with n nodes, m undirected edges. You roam the forest by traveling through the undirected edges from one node to another. You want to travel all the nodes at least once and stop when you have visited every node. Given that this is a connected graph, find the smallest lexicographical sequence of nodes that can be visited and return it in the array. So much knowledge is needed, so much knowledge and so much thinking skills are required to solve this problem. So guys, basically they are trying to say that we will give you a graph of n nodes, m edges. Start traveling that graph from wherever you want, and then you stop traveling also. Whenever you travel a node for the first time, you have to write that node, output the number of that node. Finally, whatever sequence you have outputted, that sequence should be lexicographically minimum. Lexicographically minimum means you have to prioritize and try to make the first number minimum, and then try to make the second number minimum, and like that. So let me make a graph for you. Okay, so I can explain you that procedure. Ram Ram. In every ingoing and outgoing breath, chant the name of God Ram Ram like this. So you can get Amar Lok, the ultimate moksha. Now, going back to the problem, let's say a graph is given to you like this: node number 1, node number 2, node number 3, and node number 4, like this. Okay. Now, how will you travel this graph so that the sequence of travel is lexicographically minimum? For lexicographically minimum, I have explained it already to you people. What I have explained? I have explained that you need to visit the smaller nodes first. So first you will travel this node. So in your sequence, first number will be 1. Then, then you will travel this node 2. Why am I going to 2? I travel this. The blue color is the part which I've traveled. I travel this edge and I come here. Why I'm going to 2? Because after 1, 2 is the second smallest number. After 2, where will I go? I will go to 3. After 3, where I will go? I will try to go to 4. So 1, 2, 3, 4 is the best answer for this graph. Now someone can say that, sir, why did you travel 1, 2, 3, 4? You could have traveled, first you could have traveled 1. And after 1, you could have gone to 4, then 3, then 2. 1, 4, and then 3, and then 2. Sir, why did you not follow this method? Someone can ask, right? Well, the answer is pretty simple. One possible sequence is 1, 2, 3, 4. Another possible sequence is 1, 4, 3, 2. Which is better? 1, 2, 3, 4 is better. Why 1, 2, 3 is 4 is better? 1, 2, 3, 4 is better. How do you check which is lexicographically minimum? First you check the first character. Here it is 1, here it is 1. Okay, tie. Draw हो गया. Chess match का draw हो गया. Second, if the first number is same in both the arrays, check the second number. Here it is 2, here it is 4. Which is smaller? 2 is smaller. This means this array is lexicographically smaller. So you should know in your head that whenever you are trying to find lexicographically minimum array now, we first try to prioritize the first element to be the smallest. Once the first smallest element has been found, second place should be the second possible smallest element after the first smallest element. So after 1, 2 is better than 4 after 1. So I hope you got the idea. But the question is very complicated. Every time you will not be able to get the answer of 1, 2, 3, 4. I will show you some special graph. Just a second. In this case, you can think that you will travel from 1. You will have to start from 1 only. Why? Because you have to minimize, you have to travel the entire graph. You will start from some node. You will always start from node number 1. Why? You will start from node number 1 because if you start from node number 1, the sequence of travel will show 1 first, and 1 is the smallest possible number which can come at the first position, which is guaranteed making the this array lexicographically minimum. It's helping a lot. So first you will visit 1, then after visiting 1, you can visit 4, right? So you have visited 1 and then you are visiting 4. Okay, so after 1 you have visited 4. After 4 you can visit 2, right? Yes, you can visit 2. Then after 2 you will again go to 4, but this time you will not write 4 because 4 has already been visited. After 4 you will again go to 1. You will not write 1 because 1 has already been visited. Now you will reach 3. So 1, 4, 2, 3 is one of the ways. 1, 4, 2, 3 is one of the ways. 1, 4, 2, 3 is just one of the ways. 1, 4, 2, 3 is one of the ways. Is there any better way? Yes, there is. First you visit 1, then you visit 3, like this. Now you go in reverse, but you have visited 1, then 3, but now you go from 3 to 1, but you will not write 1 in the sequence because 1 has already been written. You have to write a node only for one time in the sequence, for the first time when you visited it. Now you will go to 4, now you'll go to 2. So it is 1, 3, 4, 2. Now which is better? 1, 4, 3, 2, 3 is better, or 1, 3, 4, 2? 1, 3, 4, 2 is better. Why? फर्स्ट नंबर 1 बोथ सेम, नो ड्रॉ चेस मैच का ड्रॉ हो गया, दोनों का नंबर सेम है. सेकंड अब चेक करो. एट सेकंड पोजीशन दिस गाय इज सेइंग 3 and this guy is saying 4. This guy is saying a smaller number. It means this sequence 1, 3, 4, 2 is lexicographically smaller. Basically, if you had a dictionary, 1, 3, 4, 2 would come before 1, 4, 3, 2 in the dictionary. So 1, 3, 4, 2 is the smallest lexicographical path for this particular graph and note them edges. I am only making very simple graphs, but the actual graphs can be very difficult and can be very complicated, guys. So I am having pineapple salad, enjoying it a lot. What will be the solution technique? Solution technique is to forget the standard DSA stuff, and start feeling the problem in your head. Humans can think new things, AI cannot think new things. Even ChatGPT, AI, DeepSeek not able to solve problems like these. Not even this problem, I think. See, now I want you guys to listen to me. ChatGPT, AI, DeepSeek is not able to solve problems like these. Okay. Now, this particular problem, how ChatGPT performs on it, I don't currently know. I will have to check. But for now, I want you to think how will you think for this problem so that you don't fail. Also, the language of the problem is pretty obscure. You need a mentor. I helped you understand that you have to only output the sequence in the order in which you are visiting the node for the first time, but it was not written here properly. So sometimes you need other people help. So seek out help when needed for you. Now listen up carefully. Let's say this is node number one, and this is node number three, five, four, and two. So obviously you will start your traversal with node number one, right? You start your traversal with node number one. In the sequence, it is one. But now, which node will you travel next? You only have three options for the second place. Only three options are there. Which are those three options, guys? From node number one, either you can go to node number three, okay, or you can go to node number five, or you can go to node number four. So, how will you decide which one should you go? Should you go to three, should you go to five, or should you go to four? Common sense. There are three options. Should I go to three or five or four? I should take the minimum option for each index, right? Because I want lexicographical minimum sequence. So I will go to three. So now you have to imagine that from one you have visited three. So this thing which I have marked, this is the component which you have already visited. Now you can visit anywhere in this component anytime without worrying about the repetition. Why? What I'm trying to say is that you have visited one, then you have visited three. Now you can visit one again, you can visit three again, thousand number of times. Now one and three will never be added in this sequence array again because you only mention the nodes when you visit them for the first time in the sequence. So this blue component denotes that you have visited the nodes in this component, and now you can visit these nodes multiple times to fulfill your agenda. So one has been visited, three has been visited. This means that this component has been visited. Now you can go from three to one without causing any issue. So let's say you go from three to one. So guys, if you imagine this component as a single node, can you tell me what is the option available for the next sequence of nodes? From this component of 1 and 3, you can either go to 4 or you can go to 5. Which one will you choose? Common sense. For this, there are two options. Okay, I reiterate my statement and I repeat my statement. For this component of 1, 2, 3, where can you go? There are only two options, 4 and 5. So you will go ahead with the minimum 1, 4. That's it. Now, is the current component. This means what? You have visited 1, 3, 4. Now you can jump back from any of these nodes to any other nodes whenever needed without worrying about the sequence because those numbers will not come in the sequence. You visited 1, then 3, then 4. Now all the blue color nodes are in the blue component. Now you can jump from 4 to 1 anytime without any problem. You can jump from 1 to 3, 4 to 3, 4 to 1 anytime because you are now visiting the repeated nodes, and in the question it is written, not explained clearly, but it is clear to you guys that once whatever is your blue color component now, you can visit any node in the blue color component without causing any issue to your result. So listen to me very carefully now. Listen to me very carefully. Okay, so finally round is there of code forces. Okay, no problem. Now, listen, guys, listen to me carefully. This is now a component. Now, tell me if this component you consider as a single node. If you consider this component as a single node, if you consider this component as a single node, which are the other two nodes which are directly connected to this component? Like, समझो कि ये पूरा blue blue एक ही part है. Now see, this is what humans can do, AI cannot do. So now can you imagine that only 2 and 5 are the next options which are directly connected to this component. So 2 and 5 are the next options, right? Two options, 2 and 5, 2 and then 5. Okay. Like, so you will go ahead with 2, and now this component is also visible 1, 3, 4, 2, and then 5. So guys, the solution is pretty simple. I hope you got the point that you have to imagine in the solution that the component is growing. Wherever you are in the blue component, you can visit from any node to any other node, and then you can keep on traveling. So the C++, Java, Python codes and the things will be available for you in this document. This document will be in the Google chat. Okay. And yeah, best discount is going on the Oct cohort. So make sure you join it because from November, the prices are increasing. Now listen to me very carefully. 1, 3, 4, 8, 5, 9, 2, 6, 7, 10, 11. So what you will do? Red color. Let's use green color. First node which you will visit in the sequence is 1, right? This you have visited. Now, whenever you visit a node, now you will check which are the nodes which are directly adjacent to it. So the options are 9, 3, 4, 7, 8, 5. So you can iterate through, you will make a adjacency list in C++ Java and iterate through the adjacency list for node 1, which are the nodes directly connected to node 1. You can see so many options. So always select the minimum of that option. What is minimum? Minimum is 3. Minimum is 3. So it means now this much part is a connected component which you have visited. So how will you deal with this connected component, baby? How will you deal with this connected component? You will create the illusion. You will create the illusion. You will maintain the set of nodes which can be visited in the next turn. So, so if I try to say initially what is the set of nodes you can visit? Only one. Once you have written the first node 1 like this has been visited now. Now your set of nodes, this is the sorted set, sorted set in C++, Java, Python. Go research it and make it. So this is a sorted set. Can you guys tell me when you have already visited one, which are the options? 3, 4, 7, 8, 5, 9. 3, 4, 5, 7, 8, 9. So your sorted set should look like this. Once one is inserted in the sequence, now sorted set should say that, bro, these are the options. You can select any one of them. And you will go ahead with the smallest element of the sorted set. So you will go ahead with 3. So you will remove 3 from the sorted set. But what will you insert instead of 3? All the nodes which are adjacent to 3. Which nodes are adjacent to 3? 1 is adjacent to 3, but you will not insert 1 because 1 has already been written in the sequence. 6 is adjacent to 3. So now you will write 6, 4, 5, 7, 8, 9. What does this set mean? 6, 4, 5, 7, 8, 9 का मतलब क्या है? इसका मतलब यह है that the third node which you can visit, if you have visited 1 and 3, this is the component, right? Now which nodes are directly connected to this component? 6, 9, 5, 8, 7, 4. This set already tells you that number 6, 4, 5, 7, 8, 9. तो कुछ नहीं करना है. Whenever you visit the best minimum node connected, you will iterate all its adjacent nodes. Whichever adjacent nodes are new, never visited, put them in this sorted set. And the adjacent nodes which have already been visited in the past, or which are the पार्ट ऑफ द ग्रीन कंपोनेंट, डोंट पुट देम, उनका विजिटिंग ऑलरेडी हो गया है. अब तुम बोलोगे कि सर अगर 1-3 विजिट हो गया तो नेक्स्ट टर्न में हम 6 डायरेक्टली जा सकते हैं. बट आपने ये कैसे क्लेम कर लिया कि हम नेक्स्ट टर्न में 4, 7, 8, 5, 9 भी ट्रेवल कर सकते थे? क्यों? अगर 1 से 3 गए हो तो फिर से 3 से 1 चले जाना और फिर 1 से 5 चले जाना या 1 से 6 चले जाना. सॉरी, 1 से 6 नहीं, 1 से 6 भी जा सकते. सी, if you have visited 1 and 3, now you can consider this 1 and 3 as a single node. Why? Because you can travel back from 3 to 1 and it will not cause any problem to the sequence, because sequence only considers the nodes which you have visited for the first time. So you go from 3 to 1 and then you can go from 1 to 3 and 3 to 6, or you go from, see, 1 से 3 गए थे, then you can go from 3 to 1 without causing any issue here, then 1 to 5. So you can write 135, or you can go from 1 to 8, 138, or 134, or 136. When you're from 1 to 3, just go from 3 to 6 now. If you still want to do time pass, you can go from 1 to 3, then 3 to 1, then 1 to 6 again. How? 1 to 3, 3 to 1, 1 to 3, then 3 to 6. So these are the nodes, and this will be in sorted order. So this list will sort itself again automatically. You don't have to worry. It is self-balancing binary tree. Concept like that, understand them, okay? 4, 5, 6, 7, 8, 9 become magnetic. Aura needs to be attractive. So 4 will be the answer. So 1, 3 ke baad 4. Now consider this part as a single component. So 4 will be removed here. Now the list look like 5, 6, 7, 8, 9. Next time in log का number आना चाहिए. But when you remove 4, which are the nodes which are adjacent to 4? 4 is adjacent to 1, but 1 you will not put in the list because it has already been traveled. 2 is also adjacent to 4. So you will put 2 in this list. So after 1, 3, 4, the next nodes which can be visited considering this green part as a single node is, you can either go from this green part to 2 or 5 or 6, 7, 8, 9. How does this happen? You must be understanding by now. So you'll go with 2, you will write here 2, you will remove 2, and is there any node adjacent to 2 which has not been visited before? No. So you'll just remove 2 and the next is this, and keep on continuing this algorithm. Hope you guys enjoyed it and loved it. Ram Ram.